Greetings again. I'm going to do another problem from chapter 2.4. And in this problem we want not only the derivative, but also the second derivative, which we've got to get used to calculating now. And we're going to talk about that some more on Tuesday. Okay. We've got several ways to do this. We could use the quotient rule. But I'm going to do it a little differently. I'm going to write this way. So I'm going to write the square root of x plus 1 on the bottom as x plus 1 to the negative 1/2. In this form, now I can use the product rule to get the derivative, because I have two functions, the 4x and the x plus 1 to the negative 1/2. So I can do the product rule to get the derivative. Okay, so the derivative of 4x is 4. That was easy. Then I leave the 4x alone, and I have to take the derivative of this, which is going to be negative 1/2 x plus 1 to the negative 3/2 times 1. Where does that 1 come from? It's the derivative of the inside function. I had to use the chain rule. Okay, so we could clean this up a little bit. We could say y prime is equal to 4 times x plus 1 to the negative 1/2 plus, well, actually, negative 1/2 times 4 is going to be negative 2. So let's say minus 2x times x plus 1 to the negative 3/2. Okay. Now you've got two choices to make here. We could put all this together in one fraction by getting a common denominator, or we could just take the derivative of each piece. This is a difference, right? So we can just take the derivative of this and then take the derivative of this. Okay, so I'm going to start over here. When I take, this is a constant times a function. So I just leave the constant alone. I will bring that down the negative 1/2. And then I'll have x plus 1 to the negative 3/2 times 1. That part was easy. This part, we're going to have to use the product rule again. So I'm going to say minus the quantity. Take the derivative of this. It's just 2. And then we're going to leave this alone and take the derivative of this part, which is going to be negative 3/2 times x plus 1 to the negative 5/2. Negative 3/2 minus 1. Negative 3/2 minus 2 over 2. So I wind up with that. Okay. We can clean it up a little bit. Okay, so 4 times negative 1/2 is negative 2. So we could do that. Then we could distribute this negative. So we'd have minus 2 x plus 1 to the negative 3/2. And then when we distribute this, we have a negative and a negative. That's going to be a positive. These 2's will cancel, so we'll have plus 3x times x plus 1 to the negative 5/2. And let's just leave it there. We could get a common denominator. We could do lots of things to it. But then again, if we had a specific x value that we needed to know the derivative of that specific x value, oh, notice, wait a minute. Negative 1/2 times 4 is negative 2, and this was x plus 1 to the negative 3/2. And then we have minus 2x plus 1 to the negative 3 halves. So wait a minute, we have minus 2 of these, minus 2 another of these, so we actually have minus 4 of them. So we could clean it up. We had minus 2 of them here, minus 2 of them here, that would be minus 4. Them is x plus 1 to them, meaning x plus 1 to the negative 3 halves. Notice that was a 3 half. I was just checking on that because I brought down a negative 1 half here, decreased the exponent by 1. Here I took the derivative of this part, left that alone, and then here I left that alone and took the derivative of this part. So I had a negative and a negative, that makes it a plus. The 2's cancel, so I have plus 3x times that. Okay, that's not so bad. That looks a little better. Again, we could get a common denominator, but let's not. Let's stop there. If we needed to find a common denominator, we could do that. Depending on what we wanted to do next, we would have a different story. But right now, let's just leave it there. See you soon.